Good afternoon. I'm Raul Mercado, Principal for Water Resources Engineering, and I welcome all the webinar attendees for the presentation of the Town of Lake Park Stormwater Master Plan Update. The theme of the presentation is Achieving Resiliency Through Sustainable Green Infrastructure Best Management Practices. I'll be the MC, and I'll be presenting with three other folks. Jamie Morales is the Town of Lake Park Public Works Director. He'll be introducing the town. I'll be addressing the sustainability approach. Michael Mercado is the lead design engineer for Lateral Main, and he will address the GI-LIT design considerations of two projects, 2nd Street at Boston Park. And John Willie is a capital project manager for the town, and he will be addressing the grant bidding and construction management issues. With that, I'll turn it over to Jamie.
Good afternoon, everybody. I'm Jamie Morales. As Raul mentioned, I'm the Public Works Director for the town of Lake Park. Lake Park is a community with deep roots established as Florida's first zoning municipality in 1923. We have approximately 9,000 residents, and while we are small size has an advantages, it also presents unique challenges for managing infrastructure. The town is fully developed, meaning most of our stormwater infrastructure dates back to decades, making it critical for us to modernize. Additionally, our location along the Intercoastal Waterway, covering 0.8 miles of waterfront, expose us to environmental risk. We could go back, Mercado, particularly flooding and sea level rise. Updating our stormwater system is essential to protect our residents and property value. Next. The Stormwater Master Plan is a long-term guide for the stormwater management over the next 20 years. We aim to rehabilitate our aging drainage system while integrating sustainable practice like green infrastructure. This includes using solutions like bioswales and permeable pavement that will manage stormwater more efficiently. Taking phases approach through our capital improvement project ensures that the most pressing issues are addressed first, with project implemented gradually as funding become available. This allows us to both be financially responsible and forward thinking. Next. Our Stormwater Master Plan aligns with the EPA's G3 initiative, which stands for Green Street, Green Jobs, and Green Town. By investing in Green Street, we modernize our stormwater infrastructure and create new opportunities for economic growth throughout green jobs. These jobs focus on sustainable practice like eco-friendly engineering and landscaping, which helps drive initiative within our community. Furthermore, the green infrastructure we're implementing will make Lake Park more resilient to climate change, preparing us for the impact of rise sea levels and more intense storm event. Next. One of our biggest challenges we face is funding. With a small population of about 9,000 residents, our ability to expand the stormwater utility fee is limited. Our general budget is already allocated to essential services like community services, library, and infrastructure management. So we need to be creative in funding stormwater improvement. To address this, we are exploring external funding options, including state and federal grants. By doing so, we can finance critical stormwater projects without straining the town's budget, allowing us to meet our goal despite the constraints. Next. For FY24, our non-ad valorem assessment for stormwater management is estimated to be around $2.56 million. While this is a critical funding source, it must be carefully allocated to ensure we meet the demands of our aging infrastructure. This funding support maintenance and improvement to the stormwater system, but we need to ensure that the resources are allocated efficiently, given the scale of the challenges. Keeping our team well equipped and fully staffed is critical to successfully executing the Stormwater Master Plan objectives and goal. By improving standards and practice is a vital component of our plan is to review improving our operation and maintenance program. This includes modernizing our standard, better utilizing asset management practices, and ensuring that we meet the evolving needs of the stormwater management. By routinely assessment, regular CCTV inspections and condition assessment of stormwater pipes are integral in ensuring that systems' long-term health. This allows us to identify and address problems easier before they escalate into more significant costs in repair. Now I'll hand it into Raul Mercado.
Thank you, Jamie. As I mentioned, I'm going to address the sustainability approach. So when we, in 2018, May was elected as a consultant to update the Stormwater Master Plan, we were facing a very difficult situation. As Jamie has indicated, we had a small town of 9,000 inhabitants with a waterfront and the inability to secure funds to pay for the millions of dollars the previous consultants have indicated the town would need to upsize the stormwater system. So we needed to come out with a new approach. So let's take a look at the issues that we were confronting at the time for the selection of an approach. From the water quantity, the town has 10.6 miles of older 50-year plus storm sewers in dire need of rehabilitation. As you can see from the picture on the right, what was built there, and it's called mostly the southern outfall, were hodgepodge connection of pipes added through the years with no planning or engineering, meaning that there was water coming from the north, runoff coming from the north to the south to this track that runs along from 6th Street to the Tidewater. And there were surcharges introduced by not only the lack of capacity in the system, but also for Tidewater, to where some inlets were popping up on the upstream areas. There were also areas without any kind of flooding, as you can see from the blue square, that they actually had no drainage and the water was just basically impounding from any kind of rain. And then along the coast, from the 0.8 mile waterfront area, there was sunny day flooding along the Lake Worth Lagoon. From the water quality point of view, 2/3 of the storm sewer areas were discharging directly to the Lake Worth Lagoon. This is a impaired water body by EPA Section 303 list, where 83% of total seagrasses in the Northern Lagoon, especially along the time of the waterfront area, were dying because of the sediment discharges and urban runoff. The town belongs to the Palm Beach County NPDES MS4 group, has 14 outfalls that are monitored, and the town has to file a report every year. So now let's take a look at the other issues like climate change. As I mentioned, because of the town is already impacted by sea level rise, this is very important. The prediction by the compact, the 4 counties in South Florida plus NOAA, indicates that there will be a 42-inch increase in sea level rise for the year 270. On the right side, you can see on the bottom the projections for the 2-degree centigrade curve. This is a scientific curve that basically indicates the issues with the not preventing the emissions, depleting the ozone layers, and the world warming up. The predictions are about 2035, there will be an increase in precipitation intensity of about 20-30%, roughly anywhere between 2 to 7% per year. You can see from the picture on the top right, showing the average increase in temperatures in the city of West Palm Beach for the last 70 years, from 49 to 2019, 1.2 degrees, and keeps increasing. Why is this important? Because in any stormwater master planning design, you take into account the flat level of service. Typically, this is a 5-year, 24 hours for most municipalities. And for the Tunnel Lake Park, using the NOAA Atlas 14 database, we see that that is 7.47 inches. Now, if we were to take the projection for the next 11 years to 2035, let's say at 7%, the 747 becomes 8.24 inches. Looking back at the table again, that becomes a 7.5-year, 24-hour storm event, meaning that basically every 10 years, your design goes up 2.5-year frequencies. That means that by 2040 and 50, you'll be designing for the 10 or the 15 year. Well, that means that all the municipalities would be upsizing frequently. That is unaffordable and unsustainable. So what we proposed at the time was based on our experience. Made practices in Maryland, and both Michael and myself had implemented green infrastructure for the Washington Sanitary Surveying Commission, WSSC, as well as DC Water. And so we wanted to take some features from there and apply it to South Florida. One of the things that caught our attention at the time, something that the Maryland Department of the Environment, MDE, is doing for development, redevelopment projects. They call it a Sustainable Environmental Site Design, or ESD. And the idea with that is to select a site, a small area within your project site, and to retrofit it to a more natural condition. That is done by targeting the rainfall that would reduce the site developed RCN, the current number, from whatever it is to wood in good condition, let's say 85 to maybe a 65 or a 55. Come out with a volume and then apply green infrastructure, either be on the surface, on the groundwater with biodetention chambers. And the idea is that if you were to do that on the watershed basis, you keep enough with that climate change and the precipitation increases. I'd put a link to MDE at the bottom for those that want to learn more about the ESD approach. So then, because of the town really had a difficult situation, they had no ability to come up with the funds to pay for all those upsizing of the storm sewer. We felt that we could propose this sustainability approach that we had that we were experienced with in Maryland, and because in Florida has so many good sandy soil conditions, that felt like it was the right thing to do. So what we proposed was to perform a vulnerability risk and adaptability assessment. In other words, how's climate change affecting the town for use in stormwater master planning? Mention the sea level rise and the climate change upland for the increase in temperatures. Then apply green infrastructure, low impact development, and best management practices townwide. And this is incredibly important, not just in one project here and there, but townwide. So we needed the town to basically agree to that. At the time when we proposed this to town manager John DiAgostino and the public works director Richard Shirley, it took a leap of faith for them to trust us, and I'm glad we did. And they were instrumental in supporting the approach and working with the town commission to adapt this new approach, sustainable approach, by resolution, which the town did in October 2019. So the plan then was to implement it in 20 years, so 5 4-year cycles, CIP cycles. We recommended that the stormwater utility fees be mostly used just for the rehabilitation, like CIPP, for the existing 10.5 miles of storm sewers, and recommended that we use the state and federal funding for the major improvements. So how do you go about implementing GI and LIDVMPs for sustainability? It's a definition of green infrastructure, like Dr. B mentioned in his presentation. A small scale practice close to the runoff source. The whole idea with green infrastructure is to not let that rainfall that becomes runoff leave the site. The minute it leaves the site into the great infrastructure, the storm sewers, and the end of pipe system, the storm sewers to pump and detention areas, you lose half of the battle. So how do you go about doing that? Well, in public right-of-ways, bioretentions, bioswales, pervious pavement, tree pits. Private property, landscapes, rain barrels, rain gardens, urban trees, and in buildings, vegetarian roots and bioplanters, as you can see from the pictures. So that leads us into the flood vulnerability and risk assessment. In every stormwater master planning, you perform a level of service modeling analysis. But in the difference with our approach is that you have to start with the vulnerability to climate change. So you do it as a function of climate change, assessing what sea level rise and increasing precipitations would do to your watersheds. Then once you know that, then you want to apply it at the local level with nuisance floodings. And this is incredibly important because small scale practice and nuisance floodings go hand in hand, and I'll explain. Then comes flooding assessed at the basin level, such as as I mentioned before, the Southern Alpha watershed, about 500 acres. Now, we propose that the funds collected by the utility be specifically done for CIPP rehabilitation. So that means that we also propose that any design and construction be done by grants. There are many grants in the state of Florida. You can get also grants from the district for specific river areas, 319K grants, you name it. But the two that make a difference for something like this are the Florida Coastal Management Program, Coastal Partnership Initiative Grants, CPI, and the Resiliency Grants. So on the CPI grants, these are available to all 35 coastal counties. They are required to have a coastal element in the comprehensive plans, and they have 100% matching, one-to-one matching. Application closes in October, and typically the funding is from July through December. Don't let the 100% affect your thinking, because the idea over here is that if you have a lot of small project areas, again, think green infrastructure, small scale practice, you need that in a large number of the small projects. So if you were to take one or two, let's say at $35,000, and you match it with another 35,000, so then you already have $80,000 to do your 60% design plans that you can then use it for the next level of the funding, which is the resilient Florida infrastructure grants. These are incredibly well-funded vehicle. The project type is a statewide funding, meaning everywhere in Florida. It requires you to perform a vulnerability assessment that I mentioned that earlier. We started in 2010 with something that we thought was needed, but in 2025 it becomes law. So your project, when you perform the vulnerability assessment, you're going to identify what is along the coast is going to be sea level rise, and inland is going to be the precipitation increase. You're going to be flooding a lot more. So basically the entire state qualifies. If you go to the side at the bottom, that's the site for the grant, you will see the projects that were proposed. So it applies to flooding and sea level rise. Now, small communities under 10,000, like the town of Lake Park, don't have to match, in counties under 50,000. And also, the project design must be near completion or completed by the award date. As I mentioned, it was created by legislation in 2021 to protect coastlines and shores and as a defense against sea level rise. But it also applies to any flood and sea level rise issues that you may have statewide. Again, hundreds of projects have been proposed. So you can see over here, in 2024-25 cycle, 196 projects were proposed, deemed eligible at a tune of $1.8 billion, of which almost $900 million were approved. So this is a very reliable source for implementing a plan like this. So let's go and see how the town did this. I mentioned that you had the three levels: the vulnerability, the nuisance flooding, and the flooding. Let's just start with the first. How did the town go about climate change? The town got a 75,000 coastal resiliency grant to perform a sea level rise assessment, but we hired a surveyor to assess the elevations on the 0.8 miles of seawall, the structural conditions, what it would cost to replace it. But we also perform an inundation mapping along the lines of of what the state requires right now, from 2020 to 2020, using two local gauges and merging coastal surge with sea level rise. I mentioned the seawall. They did a structural assessment, exploratory excavation, probing, and come out with a cost that I'm going to mention that later. But we also did we comply with the Section 38009, the flood vulnerability assessment. This is very specific. It requires two local sea level rise projections. It's called the NOAA Intermediate Low and the NOAA Intermediate High. And it has to be used for two planning horizons, the year 2040 and 2070. It's changing this year. I believe it's going to 250 and 2080. We did that, and what we came out is we combined the two sources. The typical approach that is used for the coastal searches, you're not going to go on model because that's done by other consultants using much larger budgets. What you do is you take the static water level of that incoming wave, and in other words, you discount the velocity side of it and add that to the sea level rise and make a projection of how far inland that would go. And you can see from the map on the right that it will go a long ways, all the way past US 1 into 1st and 2nd Street. And on the north, all the areas around South Lake will be flooded as well. The information is presented by decades from where you are to 2070. And what we found out from the elevations on the seawall, that by 2000, even by 2030, there's already some breaches in the starts flooding. By 2050, Lakeshore Drive will be underwater. So it gives you a really good idea of what you're going to be confronted with. And then you have to put this in terms of how much it would be damaged. You know, what was the risk, how much it would be damaged. And you have to basically provide the overall risk assessment from low to moderate to high to severe. Once you do that, you're required to come out with an adaptation pathway. What are the options that you have? Well, the town basically has another 20, 30 years to 2050 to start doing something, but they already started doing that. You are going to elevate the first floors and making parking lots. You're going to do something, maybe the seawall gets elevated. Most people do that. In terms of a stormwater master planning, is how do you address all those 14 outfalls that are going to the lagoon? Well, you put floodgates. That means if you put floodgates, you need to put pump stations, sea level rise pump stations. The town has already done that. The two required, one to the north was done as a function of the Lakeshore Dry Drainage Improvement Project. And the one to the south is going to be done as a function of the Southern Oakville Phase 1 Priority Project, which I'll mention in a second. But noticed on the lower left that even by 2050, that will not be going to be enough, meaning that the town is going to have to elevate Lakeshore Drive to stay dried. So now let's address the other approach in the level of service, which is the local level nuisance flooding. This is the key of the program because small scale practice and green infrastructure and nuisance flooding go hand in hand. I also will address later the third one. So when we started the project, one of the tasks in Stormwater Master Planning was the outreach and communication task. Basically, this task was forming a committee, a 5-member committee, steering committee made out of the town manager, the public works director, the LMR staff, and the stakeholders. That's because we needed to find out, what do the people know? What do the managers, the commissioners knew about sea level rise, green infrastructure, all those terms that people throw and don't really put it in place. We sent surveys, and it was very informative, both to the managers, the commission, and to us as to the level of learning that it needed to be done. And what came out from that were recommendations to implement projects. The one that is on the works is to basically take the building where the commissioners meet and put rain barrels and bring that to a rain garden right in front, right by Park Avenue, where people see it, they will see it. Another one is to take in a municipal complex, an area that is fronting on Park Avenue, and create a biodetention facility with a learning display and observation area for elementary schools and children, and even high school, to learn about green infrastructure and sustainability. We're also working, the town is working with DOT. They're doing a mobility study, improving US 1 through the town, talking to them about putting bioplanters on the sidewalks and bioswales in the through lanes. So here comes the key. how do you implement green infrastructure townwide and make it effective? So I mentioned earlier that the key is not to let the runoff come off the site. So if it does come off the site after you put the bioplanters, it's going to hit the road and try to get into the system. So the idea then is to try to do something in there. And what we came out with the ability to convert 10% of the impervious areas in right-of-ways and parking lots to green infrastructure in the next 20 years to offset this warming trend. And we figured out that if we were to take 5% of the right-of-ways as a target, then we would get there. And we then modeled that to see if that was something that could be done. What we propose to do is not just use the swell and convert it to biocell, but convert it to a hybrid biocell, something that we had applied in Maryland. And we thought it would be really useful in Florida because unlike Maryland, where they have a lot of clay soils, you're underlaying with a tremendous amount of sand, especially in Central Florida. This will work extremely well. And so the idea is to capture the first century runoff or a good percentage of it, and then let it infiltrate to the water table. Now, when you do that, you also offsetting the discharge to Lake Worth Lagoon. That means the water quality. We modeled this using the simple MPS GIS-based model, also the SWAT distributed model for pollutant loadings, and then use the BMP trends, the UCF BMP tool, BMP trends tool to assess the effectiveness of those BMPs. And what we found out is that it would decrease the sediments in the 20-year period by 22.2% into the lagoon. Well, the Palm Beach group and the Lake Worth Lagoon people were static about it, and they really liked the program, along with all the other pollutants that would have been precluded from reaching the lagoon. But the key in here is that you have locations where you can do water quantity, water quality, and sustainability, because you're recharging the water table while you're doing that. I mean, all those three components are key for the GRAM process. So as Dr. Bean indicated in the previous presentation, 92 to 95% of all the storm sewers in storm events in Florida occur between 0 and 2 inches, most of the time about 1.5 inches. You get a 10, you get a 5-year storm once in a blue moon, but large events are right there, less than 1.5 to 2. So how then do you bring the concept into practice? Well, we strongly recommend that you use a 2D modeling approach. 1D links and nodes doesn't cut it. You have to do your profile on plans. When you see it in 2D, you take a high resolution, either mobile lidar with mesh with high airborne lidar, and create an EM and issue that to the model. It will tell you for the 0.5, 1 inch events, where is that nuisance flooding occurring? You can see from the map, it's very clear. And we knew already, for example, that along 2nd Street, it was very clearly a place where we needed to do that. So when you do the modeling, you get with your stormwater superintendent, I guess John Wiley from the town, and say, where is your documentation of this nuisance flooding? He came out with about 32 locations. So right there and then you go from mathematically supporting your technique to documentation where there it happens. And then you have a list of projects that you can use in the future, small scale projects to implement green infrastructure. So now let me go to the flooding level of service, the basin level of service. A lot of people, or a lot of engineers believe that you cannot use green infrastructure for larger projects. I don't quite agree with that, because if you selectively apply it, it would work. Take the case of the southern outfall. This is about roughly about 500 acres, and they have a north and a south tributary. They basically join right at 6th Street to go out into the main trunk and go from there to Tidewater, but they can't get there because of the improper sizing and the issues of surcharges. So we came out with basically a 3-level approach, 3 phases within one project. One at the marina, at the discharges, the outfall discharge, one in the center, which is Bostrom Park, which Malcolm will address in more detail, and one upstream of the watershed, where there's no drainage for a right away. And I quickly mentioned this. Here is the marina where there is a 72-inch CAP, aluminized pipe, that is deteriorating, that needs to be replaced, and is being replaced as a phase one of this project with two 60s, and they're going to have exfiltration trenches about the ancient area, and very important, a future sea level rise pump station. So you have what? You have the three components. You have water quantity, you have water quality, and sustainability, because again, you're offsetting sea level rise. The second project is Bostrom Park, which again, Michael will provide more details. Basically in here, you can see from the pictures that most of the northern tributary gets stuck basically along 6th Street. It cannot get to the outflow. So we needed to improve that connection and put it on the ground. There were no locations in the town to put any kind of surface detention. So on the ground of the park, the 3-acre park, was the way to go, with large chambers. And there comes the green infrastructure sustainability approach. Detain the peak flood by about 20-30 minutes. Let that peak by on the ground, filtrate that volume to the ground while it's doing so. And you're also doing what? Water quality. You're preventing that from reaching the lagoon. So again, it has water quality, and sustainability. Then it's the furthest most to the upstream watershed is this half-a-mile area of 10th Street that has absolutely no drainage, but it's a heavily transited area. There's a potential tri-rail station at the north end of it, and we propose a treatment train of bioswales, pervious pavements, underground filtration chambers. As you can see from the right, we will till the road. Basically, all the entrances to commercial communities would be pervious pavements, and then we would have some biodetentions going into these chambers. Again, you are now dealing with a situation where you have all three components: water quality, and that. And before I turn it to Michael, I want to do indicate that there's some key individuals, including Jamie Morales, John Wiley, the capital project managers, and John Wiley, Stormwater Master Plan, the Stormwater Superintendent, that have been instrumental in the implementation side of this program. It wouldn't have. It's great to design it and to put it on grants and paper. Another one is to implement it. They're doing a great job about that. So now I want to pass it on to Michael.
Thank you, Raul. Slide, please. Yeah, so as Raul mentioned, one of the things the town of Lake Park is trying to achieve is converting 5% of its right-of-way into green infrastructure. In this case, the project that I'm going to talk about here is bioswales. This street was a street that we had identified in the two-dimensional model as having a localized nuisance flooding issue. There was no existing stormwater infrastructure within 3 blocks. The nearest connection point would have been the southern outfall, which, as Raul previously mentioned, is an outfall that is already at pretty high capacity, and we're not looking to add any additional flow into that outfall. And in this particular case, we looked at this area and found that this section of 2nd Street had a lot of extraneous asphalt that was obviously kind of increasing the impervious area and causing a lot of nuisance flooding. So we looked at this project, this area, as an opportunity to put this bioswale, conversion process of the right-of-way into practice. And so, if you see in the photo, you could see these areas in the orange triangles. Those were all basically extraneous asphalt that had been paved. We did have the luxury of having a very large right-of-way in this location. I believe it was about 40 feet. So we were able to say, hey, what if we were to get rid of this extraneous asphalt and convert those into bioswales? Could we address this nuisance flooding problem and intercept those discharges at the source and keep them there? So we looked into that, and obviously when you do engineering in a town, an older town like Lake Park is one of the first municipalities in Florida. You have utilities that were installed a long time ago, and so when you're looking at doing a bioswale project in a town, that's been around for a long time, you do have to think about that in terms of the utilities with water and sewer, even in communications, because with bioswales, what you're doing is creating depressional storage on the roadside, and so dropping those grades, you are going to be obviously reducing cover over any utilities that may be in the right of way. So in a bioswale project, it does benefit you to spend a little bit of money and time looking at those subsurface utilities and doing some test holing and investigations to ensure that you can execute the bioswale project without having to do really intensive surgery on the utilities. So we look at the easements, we look at the utilities, and then we laid out those bioswales. Now we did have the benefit of having a very well developed two-dimensional model, so we were able to kind of calculate the amount of runoff that we were looking to intercept and store. And with this project, our goal or our objective was to, at the very least, get the runoff out of the travel lanes of the roadway, just for motorist safety reasons, but also to, see if we could execute this project and see how much we could get and also treat. And so our initial sizing is we laid out the bioswales in those areas, assuming a certain amount of that extraneous asphalt would be removed, providing, the minimum required travel lane width in accordance with Florida Green Book standards. And once we laid out those bioswales, obviously we can determine how much depressional storage we're getting. In this particular case, we found we weren't quite getting what we needed from the depressional storage alone. So what we decided to do was incorporate a subsurficial storage element underneath one of the bioswales using a storm chamber option. In this case, we're using the StormTech SC 160 LP, which is a 12-inch tall chamber, or 1 foot tall chamber, which is embedded in 57 stone, or number 4 stone, something like that. 6 inches of foundation stone below and 6 inches of foundation stone above. And using that kind of smaller limited cover chamber, we were able to increase or supplement the depressional storage with the subsurficial storage and still have enough cover to get our bioswale in and our bioswale media. And in profile, again, we're checking to make sure that we're not going to have any issues with utilities, and we're maximizing the space of that right of way and getting as much storage out of it as we can. We did have Kotler and Herring, which is a landscaping firm based in Jupiter, who supported us with the development of a landscaping plan, producing a rendering to assist us in the public outreach effort to let the community know what we are planning to do. And as you can see here, they provided us with some 3-dimensional renderings and a planting plan. One thing I would point out with plantings is that obviously you can design anything, but you do want to make sure that the plants, if you could please go back to that planting slide. Yeah, you do want to make sure that you have the plants that you want available And because, what we found is not necessarily all of the plants we wanted or that were laid out were necessarily available. So if for you municipalities who are doing this, kind of in-house, there is a great resource available at University of Florida IFAS Extension has a website which has a really great resource for native plants. That's gardeningsolutions.ifas.ufl.edu. You can go there and get a lot of great information on native plants. Or if you're working with a landscape architect, they can obviously select the right native plants for your project. Just again, make sure that the suppliers who are going to be supplying the plants actually have those plants available. Next slide, please. This is actually a shot of the storm chamber system that we installed below one of the larger bioswales. Again, this is just a 12-inch tall chamber. We did have a limited cover situation, and also, with these systems, you do want to site those subsurficial chambers above the water table so that you actually, get the storage the chamber is providing. So and this is a pretty coastal area in Lake Park, so we were able to get these chambers in and really increase the subsurficial storage aspect and get the most out of that right of way as possible. These chamber systems, if you're familiar with these, typically the way they work is one of the chamber rows will have a woven filter fabric underneath it, and they refer to that as the isolator row. And that row is typically the row that will receive the runoff first. And the purpose of that is to separate out all of the sediments that are coming in from those discharges. Now, we had the depressional bioswale storage above that, which also is kind of helping with that. But you can have, I'm sorry, if you could go back to the storm chamber slide. Thank you. You can have that additional isolator row if you're really looking, if, like, for example, if you didn't have the cover to do bioswales and you just wanted to do this as a standalone storage solution, then you could add that isolator row and get that sediment removal. Next slide, please. So here's a like a finished shot of what these swales look like, and this is from July, so it is hot, and obviously the grass is starting to brown, but the plants are doing very well. We did find in one location, because we had eliminated so much impervious area, the runoff was kind of concentrated into one location, so we did add a little flume to kind of prevent the sidewalk from getting undermined. So you see this flume here, which has some decorative river rock, and that's working out very nicely. And by all accounts, the bioswales with that supplemental storage has worked very well. In fact, pretty much eliminated the nuisance flooding with the series of larger events that we've had this year. Next slide. So Raul mentioned one of the three projects that Lake Park has going, in addition to the Southern Outfall project up at the lagoon, is the Bostrom Park project. This project is a project that was conceived because we saw in our stormwater model, next slide, please, that there was a choke point right before the Southern Outfall, which is the red line shown on the photo. You can see on the right in the black circle, we detected an area. It's basically just undersized pipes with a lot of discharge coming in to that one outfall. Plus, as you know, the outfall is tidally influenced. So we were trying to figure out what we could do to resolve this, or at least provide some measure of relief, as well as treatment. And we settled on this park. If you see to the bottom left of that or on the bottom left corner of that black circle, there's a green area, which is a recreational soccer softball field known as Bostrom Park. Given that we didn't have a lot of options here with, could we do a pond? There's just no available real estate to do a superficial pond. We decided to try siting a subsurficial storm chamber on a much larger scale than what you saw previously on the Second Street project. These chambers, we use the SC 730, which is, I believe, a 2.5-foot tall chamber. And we, again, because we had this very nice detailed two-dimensional model, we were able to identify how much discharge we needed to detain or filtrate. And we came up with a layout using this existing soccer field. So what's great about subsurficial storage systems like these storm check chambers is you can get effectively the same type of effect a pond would have, but you don't have to change the land use. And so if you're a municipality and you have large green spaces, whether it's a park or a soccer field, this is a potential option for you to look at creating a facility. The one thing you do have to factor in, though, is that while the land use might stay the same, you can pave over these chambers. You can do parking lots, you can do paved surfaces, sidewalks. Obviously, you can do grass. You cannot do building structures. So once these chambers are wherever you put them, you will not be doing any vertical structures over or even close to the perimeter of the chamber systems. So that is something you have to keep in mind if you have future land use plans for certain areas, is you can't do buildings on top. But pavements, flexible pavements, rigid pavements are not an issue as long as you have the minimum cover. So with the storm chamber system, as you can see here, this is sort of like a very early conceptual model of the utilities. It's sort of a X-ray vision view, if you will, of what it would look like if you could see through the ground. You can see we've got the chamber system laid out. This system is large, so in this case we did have those isolator rows that I had mentioned with the woven geotextile fabric, which again serves to separate the sediments from the water column before it will overflow into the other successive chamber rows. You will have an inflow structure on one side and an outflow structure on the downstream side, usually with a weir to be set at a control elevation to be determined by the engineer. But in this case, the system we're doing, which is actually in construction as we speak in Lake Park, that system is a 1.6 million gallon system. Sorry, if you could go back one slide. That system is a 1.6 million gallon system, which is just under, I believe, 5 acre-feet of storage. And that's in construction as we speak. And once done, we'll backfill, regrade, and it'll go back to being a soccer field, and no one will know what's beneath their feet. But effectively, it's a great way to provide some storage capacity, some sediment removal. Obviously, we're trying to remove whatever we can before discharging into the southern outfall and into the Lake Worth Lagoon. And we are in the process of tying that into the existing stormwater system and providing and relieving to some measure that choke point. Next slide. So the last project, as Raul mentioned, the one that's currently also in construction is down at the Lake Worth Lagoon, the seawall. This is the southern outfall project, effectively replacing an aged 72-inch corrugated aluminum pipe with dual 60-inch RCPs, as well as some additional green infrastructure supplements to provide some future, as well as a future pump station, as Raul mentioned. So those are some actual projects, actual applications of GI and that are actively ongoing in the town of Lake Park. And I'll pass that on back to Mr. Willie from the town of Lake Park.
Thank you, Michael. I see we're running up against the clock a little bit, so I'll just briefly discuss project funding through grant assistance. So for the town of Lake Park, project grant funding is key in providing the affordability for the town's needed infrastructure projects. And fortunately, grant assistance for infrastructure improvement is available through several agencies, both state and federal. As Raul had mentioned earlier, this grant assistance is available for both design and construction activities. One thing about the grant application and award process, it requires patience because there's often several months between submitting the grant application and any kind of notification of pending award or additional information needed. However, the process is ultimately about compliance documentation, starting from project advertisement, procurement solicitation, vendor agreement execution, construction performance, and final project closeout. It's all to ensure that grant funding is managed and allocated in compliance with relevant regulations. Michael and Raul mentioned the Second Street bioswale project. So for this project, the town was awarded a design grant through NOAA. This grant award led to a second grant that allowed us to complete the design and construction work for this project. As Raul previously explained, the NOAA design grant allowed the town to develop 30% plans, which were then used to prepare an application for construction grant funding. It's my personal belief that including conceptual or partially completed design plans with your grant application indicates a commitment of the applicant of both time and capital to the project. For the Second Street bioswale project, the second application allowed the town to secure 100% Florida Resilient Program grant funding in the amount of $553,000 for the entire construction of that Second Street bioswale project. It was the partially funded grant and the fully funded construction grant that allowed the town to address an important infrastructure improvement with limited town capital investment. Next slide. The time frame for securing the design grant to completed construction was roughly a year and a half. And as Michael had mentioned, the construction for that project is now complete, and we are in the process of closing out that grant. Also in discussion was the Burt Brosnan project. And again, this was an opportunity for grant funding that allowed the town to address a needed infrastructure improvement. And again, like Second Street, the town was able to secure a coastal resiliency grant, which allowed us to develop conceptual design plans that were used in the application for an additional grant funding support. The additional application resulted in an $11 million grant through Florida Commerce. This grant provides funding for completion of the design plans and for the construction project costs. The grant agency's grant management and compliance obligations are robust, but as previously mentioned, it's all to ensure that the funds are allocated appropriately. And as Michael mentioned, the current status of this Burt Brosnan project is we've met our advertisement requirements, we've met our procurement requirements with the grant agency, and this project is currently in the construction phase. So with that, Raul, I'll maybe leave it to you to a couple of closeout comments before addressing any questions.
Sure. So altogether, we can say that the sustainability approach that we proposed for master planning in 2018 and culminated in 2020 has been very successful. The town has been able to receive since 2020, $18.2 million in funding for the implementation of the projects. Here's the list, including the largest award at $11.1 million. I had to mention a couple of people. Roberto Travieso succeeded Richard Shirley as Public Works Director, and he was also instrumental in moving this project along. And Merrill N. Wright, the grants person at the Town of Lake Park, the specialist. If you don't have one, you need to have one like her, because it takes a grant writer and a lot of experience to put all this into paperwork. Like John said, it can be sometimes a little bit overwhelming, but it's worthwhile when your town of 9,000 people can get $11.1 million. So with that, and then I'm going to open it to questions.
Raul, I believe we did have one question about the design event for the chamber system. So for the large system, the Boston Park project, I believe, if Raul, correct me if I'm wrong, that the design criteria was SFWMD for the 25-year, 72-hour storm.
Yes.
For the smaller system, which was the nuisance flooding project, I believe we were looking at a much smaller event in that case.
Yeah, we found out, as Dr. Vin indicated, that the goal of it all, and it's somewhat of master planning, is trying to achieve a level of service. Municipalities usually like the 5-year one day. However, when you take a lot of small projects like we did with here, we looked at it, the 3-year one day was the one that seemed to produce the amount of nuisance flooding that correlated with the locations where John Wiley, the Stormwater person in charge of the maintenance of the system, was telling us that was documented. So we use that as the criteria, the 3-year one day. And when you put all those together, it really does make a difference. It makes a dent in holding all that water for getting into the storm sewer system.
And then we had another question asking if we could show the scan code again for the list of resource links. I believe must be like a QR code for the resource links.
Yeah, I guess I need to stop sharing for that. So any other technical questions for this?
I saw one more question just popped up. What is the average utility life of the infrastructure showcased in this case study?
Michael?
I believe the storm chambers are 50 years, but I don't, hang on, I can tell you. Let's see.
That was about between 50 and 75 years.
Thank you.
They're polypropylene. They're polypropylene chambers, so about the same as any polypropylene pipe product from like ADS.
Yeah, we said a minimum of 75 years.
Well, gentlemen, thank you for an outstanding presentation. That wraps up our 2-day seminar, webinar, should I say? An outstanding presentation. And until the next one.
Thank you.
Everybody, have a good afternoon.
Be well, be well. Thank you.